Namaste. Welcome to Unite India 2017. Our first ever Unite here in India. We're super excited to be here. Thank you so much for coming. Attendance for this first event is incredible. More than 1,300 people signed up and are here. So thank you so much for coming. I really appreciate that. It's incredible in this very room how many different creators we have. We have indies just getting started, as well as established studios, companies, some of the largest in India. We have people still in school. We have people from film, games, architecture, and more. And then in terms of the roles that we do, we have programmers, designers, artists, producers, and many more. A big welcome to everyone. Thank you for coming. If this is your first Unite events are where we come together and share. And I want to kick off by sharing something really incredible with you. In the past 12 months, we have been amazed at everything you created. And games built with Unity have surpassed 20 billion installs. That's amazing. And that's 654 installs per second, per day for the last 365 days. You're absolutely dominating the charts. On mobile, the largest set of platforms, 40% of the top 1,000 games are made with Unity. And new mobile developments, that number is a staggering 50%. What's even more incredible is in AR/VR, content built with Unity is 60%. Across all 25+ platforms, you are creating some truly amazing experiences. Let's take a look. It's incredible, isn't it? Every time I see these show reels, it literally gives me goosebumps. I mean, year after year to see the incredible progression of our industry, it's absolutely amazing. And it's not just games anymore, and it's not limited to just normal devices. Now we're moving into AR, VR. So thank you all for all that you do. It's simply amazing. In bringing you our work, we're inspired and guided by 3 principles. The first one, our founding principle, is democratize development. We live in the era of the creator, the maker, and we know that creative expression is a really beautiful thing, whether it be writing, music, videos, movies, interactive experiences, games. We believe the world is a better place with more creators in it, and everyone deserves and should have access to the most powerful creation tools possible. And together, we're changing the world. And our second principle is solving hard problems. The creative process is a really tough journey, which we all know. And it doesn't matter what you're making. We strive to solve the hardest problems standing between you and your creative vision. enabling you to iterate rapidly, allowing you to extend and enhance Unity to meet your own needs, and increasing your reach to as many platforms as possible. These are some of the problems that we tackle every day. Our third principle is enabling success. And we each define success a bit differently. Some of us could be the number of people that experience or enjoy the stuff we make. It could be the number of projects you publish. It could be the number of dollars you make, your financial success. It could be getting the best grade in your class. Or it could even just be the basic satisfaction of, I made this or I made that. Our three principles shape what we make and bring to you, and we've been using them to power our latest release, 2017.2. 2017.2 was released a couple of weeks ago, and I do want to say a big thank you to everybody who helped test it as part of the beta, ensuring that it's the best product that we can release. We continue to pay particular attention to what matters to you most. First and foremost is quality and stability, and it's our ever-increasing push in this regard, solidifying the foundation you rely on to build great products. We work hard on fixing the issues that matter most to you. We've also invested heavily in core engineering, and we're going to be 500 strong by the end of this year. That's 500 engineers working for you, located in 37 cities around the world. 500 engineers instrumental in bringing you 2017.2. Once you have a stable foundation, you want to squeeze the maximum performance out of each and every pixel that you can get. And we're innovating and undertaking major improvements to Unity with incredible revolutionary results. And I'm excited to say that later on in this keynote, I'm going to actually demonstrate and show you some of those things. In terms of graphics, we continue to learn since the release of Unity 5. With your feedback, we focused on things that are important to you, like fast, flexible, iterative light mapping to keep you productive, industry-leading post-processing effects to make your content look great, rebuilding our renderers, making them more scalable, more accessible, and much, much more. We're going all out to bring you the best platform-specific, performant rendering engine possible. We also know that support for artists and designers is very important. No longer a tool for just programmers, features like Timeline, Cinemachine, and the post-processing stack give artists the control of the creative vision they want and need, and all without code. And we're not done. We're making big improvements to creative tooling and workflows, enabling the whole team to work better together. You also count on us to continue to provide industry-leading multi-platform support, with over 25 great platforms to ensure timely and seamless integrations, build once, and with minimal work, deploy anywhere, enabling you to reach the largest audience possible. With big improvements to quality, stability, performance, and features, and a sizable engineering team working for you, 2017.2 is the most powerful engine and complete toolset we've released to date. We're very excited to show you more, so let's get started.
My friend Wes, who's a super brilliant technical artist, really wanted to put a constraint on himself. Using only asset store content to create the perfect image what he wants, the goal he had in mind. He brought in the content, and he didn't have to do any changes, just only moving around, but he didn't have to focus on creating something. Right? That allowed him to focus on the objects to make the image beautiful. On top of that, he applied the post-processing image stack, and there he really brought the volumetric lighting, the plume, even occlusion, and that allowed Wes to really wrap a prototype with using the asset store content, creating his own goal. Using the asset store for creative prototyping allows you to identify the objects you really want to focus on to create a unique project.
Please welcome Callewaert.
Hello. Wow, what a crowd. Amazing. I'm super excited to be with you here at Unite India, the first time. It's also my first time in India, so thank you for the warm welcome. Thanks. We all creators here, Every day, we have ideas to create new projects in Unity. We might have some content to start with, but how do we go from an idea to a final project? Our in-house artist, Wes, had also an idea. I will show you how he went from an idea to a final project in just over 2 days. We like to call this project Neon. Right, like neon. Okay. When Wes started with that project, he put an extra challenge on himself. He wanted to see how far he got in the project. He wanted to see how beautiful the project could get, with no spending time on creating content. I will show you how he went from an idea to a final project in an interactive way. We like to call that creative prototyping. I have the scene open on my computer. Let's have a look. So it doesn't look much. Right? There's a few buildings here in the scene. Nothing special. Right, those assets, Wes took them from the asset store. It's the sci-fi pack. We also have some cubes here. Everybody has used a cube. Cube 1, 3, 4, 5, 6, 7, 8, 9, 10. If you've never seen that and never used Unity. Yeah. So we have them, and here he blocked out like a little street. And let's look at that street. Okay. Let's align the camera with the camera he actually set up. It's not looking engaging. It might something look like when you and I are creating something, some blocks, and adding some objects to the scene. Adding light to the scene creates a depth feeling. We're adding contour, we're adding shading to the scene. Let's add some more objects to the scene. Let's add some area lights here. You might be wondering, how is that done? Well, this button is just a simple script that really activates this game object on and off. So with that, we're putting some more focus in the scene on certain areas. When Wes starts the creative prototype, he really advises you to use 2 packages. You can find them on the asset store or GitHub. It's the post-processing stack and the Volumetric Fog. Okay. Here we attached already, and this as a component, the post-processing stack. You just import it from the asset store and attach it as a component here. The first thing I do is to add a little bit more reflection, getting more depth in that scene by activating screen space reflection. So look now, when I move this here, you see nicely that reflection. I'm very good for puddles and wet areas. The other package that Wes talked about was a volumetric fog. Let's activate this. Wow. This is a real impact. It really changes the scene. Now let's tone down a little bit. We're going to tone it down by using auto exposure and color grading. Let's turn down the volumetric fog here. So what you see in that volumetric fog, it's not just like linear, regular fog who's linear. We see here different densities in the scene. Because it's using the area light, let's add here the area light, and it's using the density of the scene. Let's align our camera again. Okay. So when I bring up the fog here, it brings up. But when I bring it down to 0, that is basically just a direct contribution of the light in the scene without scattering in the fog. Let's bring it back up. We're getting that cyberpunk look that we're going after. Color grading. And color grading is editing or enhancing the color in my scene. It's like light. It gives a mood and a feeling to my scene. So I can change the mood here. I'm going to, on the fly, real time in the editor, not rendered, not in the game viewport, right away in the editor, I'm changing this. I'm going to make it a little bit colder in the darker areas and warmer in the highlights. On the fly, I'm doing this. It's really impressive that one artist can create a prototype and very fast get to his look that he wants. Then he can communicate with his friends and define like what else are we going to add in the scene, which objects from the asset store are you going to create to bring in that scene. Okay, let's add some more objects in this scene. starting to look beautiful, all those objects. But let's bring them more out, those objects, by adding soft shadows. That's why we're going to add ambient occlusion in this scene. Look, turn off, turn on. You see nicely the impact. We're going after that look of the cyberpunk feeling, and we know what to add now. Now we can add some neon lights. But we're really looking to the real lens. We're used to that. So we're going to add the glow to the neon, adding bloom, the feathering of a light in the fog around that neon light. Because we're looking through the lens, let's add some more things. Aberration, and the artifacts here in the corners, look, turn off, turn on. You nicely see that. We get the feeling we're looking through a lens. Let's add some vignette, and the decolorization, and the corners when you look through a lens, a natural thing from the lens. Let's bring it a little bit alive with adding some fine rain in there. Okay, you might be starting to wonder, hey, where did we came from? Where did we start with that project? Well, let's turn off all the effects. This is how it looks when you put all the objects together, and in a few clicks, wow, this is what you get. Let's add some humans to the scene to bring it more alive, some depth of field, and let's play what is the scene is now about. Beautiful. We animated the camera here, we're bringing it down, and we just added a depth of field. The depth of field is the sharpness between the closest point you define and the first point you define. But we're focusing now on the car. We're using that to tell an intelligent way to tell a story. Okay, let's look a little bit more at that scene. Let's go in that scene. I'm going to take the camera and take it away from the animator so I can freely walk around. Let's talk a bit more about that creative processing with using existing content. Look here, look at that object. It's like a nice sewer system, a pipe system that works there. But is it actually that? This is the beauty of creative prototyping. You can use any object. You just paste there, you see what it gives, and you're creative working. What is it? Well, let's look here into my scene. I'm going to zoom out. Now look here. Well, we have the same object here. And it just turns them up, it's a building. That is the beauty of creative prototyping. It's not because it's labeled as a building that you have to use as a building. This scene is full with those tricks. Let me go back to the game here. Look here on the other side. When I look on top here, I see a roof full with cables. When Ves was working on that, he was looking for cables but didn't find anything. And he was thinking, well, maybe I'm going to break the rule and create it. But creative prototyping is use something and see what it gives, and don't follow those rules. Something is labeled as cables, but look what he actually used. Let's have a look at this. Anybody knows what it could be? So let's have a look. 1, 2, 3. It's a spaceship. Pretty cool, eh? It's pretty impressive how one artist can creative prototype using the volumetric fog, the post-processing stack, and some assets he had before. Well, when we gave this scene to Adam Myhel, he got totally excited. Adam is our in-house camera specialist. He got so excited, he really wanted to bring that scene alive with adding some camera shots to tell his own story in there. He was talking about the language of the camera to me. We're so used to look through the lens of a camera by watching thousands of hours, watching movies and playing games. When the natural motion of a camera is incorrect or not natural, we feel that right away. That's why Timeline and Cinema Machine bring you that natural look to you in a procedural way. You don't need the program, you don't need the script, you don't need the keyframe. Let's have a look at that. Okay, let's look here. Okay, same scene, it's neon. What we have here is Timeline. Timeline is a linear storytelling tool to bring you to tell your stories, cutscenes, cinematic stories, and even advanced audio sequences. And you can have different tracks in there, like for your camera, animations, audio. Adam placed here an audio track to give him a certain mood and a certain feeling to his scene that he wants to bring alive. These clips are cameras. And each with their own settings. They could be a still shot, they could be animated, they could be procedural. Let's have a look at this. Let's have a look what's the story he created here. We have a procedural animated camera, and then using the depth of field here. This camera shot is following that human in a specific composite on screen. Here, following it also, and then blending to another shot. Just pull a bit back. Here, the natural feeling of holding a camera and while you're breathing by adding procedural noise to it. Here we're blending actually between two different camera shots, static shots, to highlight that character. Zooming in nicely. Again, here we're following that drone procedurally. So in creative prototyping, when you move the drone and you're seen, it will still all work. Okay, we are neon. And we're going to pull back here to a blurry shot, wrap up the story, and finish it. Hey, how was that end done? How do we do something like that? Was it animated? Was it keyframed? How do we do something like that? Let's have a look at that. Okay. This clip is a camera clip with some procedure noise. The beauty is that you can have, every clip can have its own settings. Like here, right, we have the post-processing stack and we put it fully out of depth of field. This clip is that camera that pulls back a little bit with some noise on it, procedure noise. How do we blend those two clips now? Very complicated. Click, and you blend it over, and there we got it. Already done. Now the beauty is in this style that, look, you can make other tracks, you can make other stories on the fly. Like, look here, I'm gonna mute this track and mute this track. And Adam told another story. He brought some other camera shots in there in the same scene, and he told another story with another audio file. Press play. Let's look at that. Wow, that spaceship is coming down. And we're following that spaceship. Getting a close up. Comes in and I follow that. See, look, we're following here also that probe, but you see the composition changes, how the scene is set up. But we're still following it procedurally. And we're going to blend in here. We're just going to animate like in the image filter to black and white with the blue channel active. You see another story, a little bit upbeat, changing the camera shots, pulling back out to wrap up that story. But how do we do that tracking? Let's have a look at that. Look here. This is the clip. We're following that spaceship, and here we're zooming in. Okay, how is that done? We have that every clip has its own camera, and we animated the field of view. Look at that slider, and we just blend it in. But how do we follow the spaceship? Well, you select the game object, and you drag it here in the field of look at. Look at that object. How do we know that? I'm going to add here my overlay helpers on it. So that yellow dot, now you can see, and we're following that spaceship. Follow, 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 follow. Super easy. But hey, I want to change how the composition is on the screen. And how we follow it. This is the beauty. Right? How do you change the composition? Well, click, and you move it around. Super simple. So now I'm going to get another angle. And look now, this is all procedure nicely working. This is the beauty of Cinema Sheen and Timeline. It's pretty impressive how one artist can bring a scene alive with using those features. This project Neon, Wes, used content from the asset store. But you, when you create your own projects, you want to create your own content, use your own content. It's already super easy to bring in content into Unity. Guess what? We're going to make it even easier. That's why I'm pleased to announce our new partnership with Autodesk. Unity 2017.2 is the first game engine to have direct access to the source code of the XBX file format. This gives you an easy pipeline between Maya and Unity, back and forward. Let's have a look how easy it is. We have a cube here. Maybe we prototype in Unity. We bring it in Maya. Simple, back and forward. We have it here. Let's change another model, maybe a spaceship. We can add also custom shaders to it, or here the Stingray shader with its own settings, such as the reflections and glossiness. When we export that to Unity, guess what? Bang, it's all there. All those settings are there. Awesome, yeah. When you do changes in Unity, like adding a box collider, you want to make sure it goes back and forward. When you go back to Maya, and you do changes to that, like change the wings here, going to make the spaceship a little faster to fly. And then, when I go back into Unity, there it is. All those changes are preserved. I can't wait to see what you're going to create, but before I leave, I want to do some color grading. So we're going to take here a picture, and then use Instagram to color grade it. So smile, everybody. I'm going to color grade it and upload it. Thank you, and I can't wait to see what you create.
Thanks, Carl. You know, when I first saw this demo, I was blown away, but probably not in the way that most people think in terms of it looks beautiful. When it first pops into the scene, I'm like, that looks just like the stuff I make. And I'm a programmer, so I guess we've all had that experience. But then to see that now, right inside Unity, that you can very easily go from, you know, kind of blah to wow, it's really, really incredible. And those things that Carl said about the asset store for the post-processing effect stack, those are from Unity. They're absolutely free. You can download them, integrate them into your projects. As I mentioned before, we're here at Unites because of you and your passion to create, innovate, and bring the world new experiences is what really drives us at Unity. We don't make our own games and content, so we love everything that you guys do, and it really, really excites us, and it fuels our passion. Let's take a look at a few of those stories right now.
What inspires me is the passion basically towards the games. So since childhood, whenever I was playing a game, I always wanted to do something like that. So that was my career objective since I started playing games in my childhood.
For me, the biggest inspiration is the overlap between two very separate domains. One is art and the other is engineering. And this overlap is where 3D computer graphics, 3D animation and 3D gaming happens.
So we've been using Unity for the last 3 years. Currently, majority of our development happens on Unity, and we're using Unity for creating both virtual reality and augmented reality environments.
When I first went to my college, I think really, I looked at the place and I said, hey man, this is the thing. We can create a career out of game here.
Make it a mixed reality for you in your real life. That was my aha moment.
I've been using Unity for a little over 8 years. Primarily, I started using Unity for gaming. But right now, we concentrate mainly on non-gaming products using Unity.
Unity is a user-friendly platform. It's like a game changer in the gaming industry.
Working as a developer or an artist in India is not so simple actually, because there is no formal education system for learning game art and game engines.
The biggest challenge that we faced was really finding the right team, right talent, right skills in India who knows Unity, who knows AR/VR.
The thing I love the most and I also hate the most about the creative process is when you say it's finished, because it's never finished. You know everything that's wrong with what you're putting out. So I think that's the best part about the creative process.
The best outcome of my project is gaining millions of users in a couple of months.
The best outcome for our project is when we are actually able to ship it, deliver it to a lot of users who then are able to literally experience it for themselves and come back to us and tell us what they think about it.
So when people experience my game, I want them to feel a lot of emotions, not just one, and probably the emotion that we are intending for and not the wrong one.
We want them to feel happy. We want them to feel immersed. We want them to feel complete.
I create because it inspires me to build better products for the future, to make sure that whatever we are doing is not a repetitive task again and again.
I create because our games make people happy.
Thanks to everybody who shared those stories with us. It's really one of my favorite things at Unity. So for these couple of days, if you see us around, and especially me, by all means, come up and share your story. We really, really like them. So thank you for that. We're going to shift gears a little bit. Unity, over the last few years, has been steadily improving our 2D tools by our team in Singapore. And let's take a look at what they've been up to.
For the past couple of years, we've been really hard at work on foundational 2D features at Unity. This is an important area of focus for us, because even though we want to work on the high-level features, we want to make sure that they're built on a strong foundation. We're really excited that this year we've completed most of that work, and we're ready to switch gears and release the first of our 2D layout tools. This is TileMap, which we're releasing with 2017.2. This is a tool for building grid-based layouts in games. I personally feel really strongly about this tool, because I can see artists and designers using this tool to express themselves in Unity and literally paint right in the scene. Another thing that's new is Cinema Sheen for 2D. Now this is going to bring all the power of procedural cameras to anyone making 2D games. This way, you can focus on tweaking your cameras and stop writing code.
Please welcome Russ Scammell.
Good afternoon, everyone. It's a pleasure to be here at Unite India. It's been a really good year for 2D at Unity. New with 2017.2, we're happy to introduce TileMap. This is the first of our grid-based layout tools, and we're going to be along with the TileMap collider that comes with it, you can create collisions for your tile maps. Now, earlier this year, we've been releasing other important 2D features. We released the Sprite Atlas asset, as well as the Sprite mask component. We've also been making important work on sorting. We released sorting groups, as well as axis distance sort. This is to help those of you who are making 2D games with the tricky problem of sorting in 2D. Also new with 2017.2, Cinema Sheen for 2D. So we've added a number of new features to that, which makes this a powerful 2D camera system. Now we're going to take a look at all of these features in action using assets from a game by Epic House Studios. Phased was one of the first games to be made on our new TileMap feature. Now this is a unique Made with Unity title that makes creative use of pixel art, as well as glitch effects to reinforce the story of a girl who wakes up to discover she has the power to twist reality. Now we really love how they've embraced the whole vintage throwback art style. And they've added some sprinkles of modern effects too, like chromatic aberration and distortion buffers for some of the effects. We'd really like to thank the team at Epic House for allowing us to use their assets for this demo. Now I'm going to build a level from Phased in TileMap. Now, TileMap gives me a smooth workflow for importing images that I've prepared in my art authoring tool. And I can bring these into Unity as sprites. I can then drag these directly onto my tile palette here. These create tiles, which I can then paint onto a tile map in the scene. Now I'm going to start by painting the walls of the level. And to do this, I'm going to use a custom tile. So this is a rule tile, if we look in the inspector here. And this is for designers to define relationships between different tiles, between neighboring tiles, so that when you paint these in the scene, we can choose maybe a corner or a side, or maybe a random tile automatically. Now, you can create your own, right? And you would do this by extending the tile class. But of course, we wanted to get you up and running quickly. So we've provided a set of custom tiles and brushes as part of our 2D extras. So let's get going. I want to start painting in the scene. So all I'm going to do here is select that tile. And with the paintbrush tool, I can come in here and just start getting productive immediately. So we can see we're getting automatic corners and edges. That's quite fun. Or maybe I want to go a little bit faster. I'm going to come in here and use the box fill tool. And really quickly, I've laid out a level. Now, I want to make this wall a little bit more colorful, right? It's looking a little bit beige at the moment. I want to fill it up with color, and I want to add multiple layers. So I want to do this with posters. Now, this scene has been set up specifically for this. We've got multiple tile maps for exactly this reason. Now, what I'm going to do is select on a different layer. I'm going to come in here and I'm going to paint in these posters. OK, so let's come in here. And then on this layer here, I'm going to put in some posters. OK. And then on yet another layer, I'm going to put in more. Right? There we go. So we've got this layering effect going on. Right? And you can sort these using everything that you normally use to sort 2D. So your sorting groups, or your sorting layers, or even your ordering layer. Now I want to keep going. I want to put down some furniture. Okay, so I'm going to grab the bed here. I'm going to put that down here. I'm going to grab some side tables. Right? So you can see I can get productive really quickly with this. I want to put a room divider over here, finally. Okay, and then maybe a door. Right? Because otherwise our player's going to get stuck in the level forever. OK, great. So just like that, we've got a level going. Now let's say you're working with some normal sprite renderers. Right? You just want those to work. So let's take a look at this. So here I have some props. Right? Here's a fan and an alarm clock. And these are just ordinary sprite renderers that are just working seamlessly together with the tile maps. So that'll work just fine. Now, some of these tile map layers are purely aesthetic, right? It's just for visuals. But in preparation for gameplay, I want to add a collider to one of these tile maps. And the reason I want to do this is so that when I put the player into the level, she doesn't just fall through the floor, right? So let's take a look at the tile map collider 2D. I'm going to select the walls here. And I'm just going to turn on the tile map collider. Now, as you can see, this is a collider that's been designed to work specifically with tile maps. So it fits the sprites really neatly. And the reason it does that is we're using the physics shape data from those sprites that are used in the tile in order to define a really tight-fitting collision shape. Now, this also works together really well with the Composite Collider 2D. So let's turn that on. And we can see we've now optimized that shape. So that is going to work a little bit better in your scene. You're going to get a little bit more performance. Now, game design is a fluid process, right? So we've made a level like this, and you've gone, OK, cool. This is great. But maybe I want to make it a little bit bigger. And normally, you would have to redo all your collisions. You'd need to redraw them. Or maybe your art director has come to you and said, hey, I want that ceiling a little bit higher. And you're like, OK. So I'm going to come in here. And on the walls tile map, I'm just going to come in and start editing those walls. I want to make that ceiling a little bit higher. OK. So you didn't have to make any changes to the collider. That just updates automatically. So it's a really flexible system. OK, finally, let's add a player, right? We need some motion in this scene. So let's open this up. This is the player. And again, she is just a sprite renderer with some scripts on her and a collider. And we can see when we hit it, this is all just working nicely together with the tile map layers, right? Everything blending seamlessly. Great. OK. So it's Halloween season, and I thought that it would be a good idea to get festive with this level, to make it a little bit more, to add a little Halloween flavor. Now, I've already noticed, those of you who have been watching closely, that there are 2 jack-o'-lanterns hiding in that tile map. So that's already included in the project. And what I want to do is I want to activate my Halloween theme remotely. And I only want to do this for my players in India, right? So how do we do this? Right? I want to activate this theme. I don't want to deploy a new project. I don't want my players to download a new game. And I only want it for a particular segment. So I'm going to show you how we're going to do this with an improvement to an analytics feature called remote settings. And that improvement is segmented remote settings. So what we see here on the analytics dashboard is I have a variable there called isHalloween, right? And currently it's false for everyone in the world. What I want to do is I want to bind it to India, and I want to turn this to true. OK, I'm just going to synchronize that. OK, we're going to wait a while before that sets in. Keep in mind, I haven't made any changes to my project, right? I'm just going to hit play now. And suddenly, it's Halloween in the world of phased, right? This is a really powerful concept, right? The idea that you can activate different ideas in your games by segment remotely. Now, you can use this to roll out features gradually. You can also use it with standard events to monitor the impact through your analytics dashboard. And of course, you can test your creative ideas on different segments, right? You can try something out in the US, try another thing out in India, and then you can try something out on iOS or Android, and then see what works. OK, I want to switch gears a little bit. I want to take a look at a larger part of the phased universe. This is the main town from phased. And what I want to do is I'd love to explore it. Right? It looks like a much larger level. It looks like there's a lot more going on. But I don't have a camera to follow me around. Right? So I'm kind of stuck in this area of the level for now. So this is a good time to talk about game cameras. Now, game cameras end up being these really large, unwieldy balls of code, right? Because you start with a simple idea. I want to follow cam. And then you're like, OK, I want to add a different behavior. I want to add something else. And with each of these comes more code. And sometimes those ideas don't gel together well. Your tuning and iteration becomes slow. And every time you want to add a new idea, a new behavior, it means more coding. Now, Cinemachine allows you to create smart cameras which follow your direction and it's really easy and it's really quick to add new behaviors to them. So I'm going to add the new 2D cameras, right, from Cinemachine. So I'm going to add one here, create 2D camera. And we can see that it creates a virtual camera in the scene. So I'm going to select that. And let's take a look at it in the game view. Let's see what that looks like. OK, so we seem to be a little bit far away from the level right now. So let's fix that. Let's zoom in by decreasing the orthographic size. OK, there we go. Something like that is probably good. And then I'm going to change a couple of values over here, but we'll come back to them later. And then finally, we want this to follow the player, right? So I'm just going to drag the player into the follow field of the camera. I'll hit play. And in just a couple of clicks, we have a nice follow cam, right? So this is really good. I'm not too happy with the movement. It's a little bit mechanical for me at the moment. So I want to make some adjustments. So what I'm going to do first is I'm going to increase the deadzone width. Now that is this size here. This is the dead zone, the space around the player, where if the player moves, the camera doesn't necessarily follow yet. But as she moves into the balloon zone, you can see the camera starts following her. Right, so this is quite nice. So it's going to lag slightly behind. I still want that to be a bit softer, so I'm going to turn on the damping here and here. Okay, and now when the player moves, we've got this really nice soft follow cam. You may have noticed something else that I'm doing. I'm making all of these changes in play mode, right? Now, those of you in the audience who have played with cameras, the artists and designers who have spent time tweaking these systems, you realize that they are very much living systems, and you want to be able to make those tweaks at play mode. It's a vital workflow to make sure that these changes to your game are persisted. So how we do that? You'll notice here, under the Cinemachine virtual camera, we have a save during play. So all of your tweaks, all of that hard work that you put into it, that's just going to be fine. OK, I'm going to show you one more thing. If we come over here, there's a little bit of a story that happens in this part of the level. So as you enter that zone where there's a stack of TVs, we tell you a story about phased, right? And we've also added a little trigger there so that as you enter that zone, we activate a camera. Now, the difference is when you activate a camera in Cinemachine, it blends your camera settings from your current camera to the one that you just activated, as long as the new camera is a higher priority or the same. So let's take a look at that. Okay? So I really love how this small change in behavior creates a dramatic effect. You're being pulled into the world of phased, and you're being given some information, right? There's a story. It looks like there's a party that you have to attend, right? And suddenly, there's a strong feeling that you're connected to the game, right? I'm really excited about TileMap. I think it's going to be great to see what artists and designers using custom tiles and brushes are going to do when they express their creative ideas right in the scene. With the associated collider, this is going to be a great way to create 2D grid-based layouts in Unity. With remote settings, especially the segmented remote settings, you can now make changes to your game, or you can activate changes to your game after launch. So you can tweak, and you can try things out in different segments, and you can create the best experience for your players. And with Cinemachine 2D, we've made all these features for 2D so that you can spend your time creating really cool cameras and get away from writing code. With 2017.2, Unity now has a great end-to-end solution for 2D games. If you'd like to see more on this and the other 2D features, I'm going to be doing a talk on track 2 from 4 to 4:30 tomorrow, so check that out. There's going to be all the new 2D features in Unity. Thank you very much, everyone.
Thank you, Russ. Super exciting. It's really amazing how easy 2D is becoming in Unity. And prior to that, we saw Carl's Neon demo with rapid content development right in Unity, accelerating success for everyone on the team. Earlier on, when I covered the performance side, I said that there's some revolutionary stuff we're working on, and it's time to take a peek into the future of Unity, so I'm going to show you that. For most games, Unity works really well. We have hundreds of thousands of games in active development, many more than that released. Obviously, Unity puts food on the table for many, many people, and it works great for most use cases, and it's getting better all the time. But for some use cases, we need absolutely extreme performance, and we've been thinking a lot about that. And I'd like to show you how we will enable such performance in the future. And to get started, to do that, I'm going to need some content. So we partnered with Nordeus. It's a small studio based in Belgrade, Serbia. That's them there. And we worked together on a MOBA to showcase their performance improvements, because there's a lot of stuff going on. And we did that by taking assets from one of their games called Spell Souls, Duel of Legends. And I'd like to show you what we came up with. So to do that, I'm going to jump into the editor and get this game started. So here we are, just right in the editor. Hit play, and let's watch the intro and get into the game. Stuff up. So, and what you saw just there was actually all live running in the editor. This isn't a movie. It's actually, as you can see here, it's just in play mode. And we got a lot going on here to really stress test our performance stuff. We've got platoons that are doing overall pathfinding. We have units that are doing pathfinding, finding, merging different platoons. Of course, we have these number of arrows here. And then, of course, we have really nice spells. Let's play with some of those, because that's my favorite thing to do. We can go down, and let's wipe out. This is my favorite one right here, this little angel thing that comes. So a lot going on, and this is actually pretty good. I mean, this is quite a lot of stuff already, but I think we can do a lot better. You can see right now on the upper left-hand corner of the screen, we have 8,000, 9,000 things going on at once. But let's bump that up. Let's see how much more we can create. Let's just keep adding and adding. And of course, we're doing this all live, instant instantiation. So let me just keep bumping here. I don't know. I'm thinking somewhere around 70,000. Feels pretty good. I'm sorry? The system spec? Yeah, can we talk about that? Let me get through everything, show you everything, and then you can ask the question. Is that okay? So we've got, but it's just a desktop PC. I mean, there's not multiple racks of PCs here. This is one single PC with a graphic card. So now we've got, and obviously, a lot of things happening, and I can still do the same thing. I can still, lots going on here. Obviously, lots of arrows. We can have some mayhem over here. Let's do one of these. Those. So we have an incredible amount of things actually going on the screen right now at once, and still at a real-time frame rate. How did we do that? So there are 3 key innovations that is running right now that I'd like to talk to you about. So what I'm going to do is I'm just going to switch over to the profiler, and we have that running here. And I'm just going to stop recording the profiler for a second and just click on some random frame, and we're going to go in. So first thing, innovation that we have is C# job system. So this means that all of your user scripts are now multi-threaded. And for those of you that know Unity from before, we basically have all your scripts running in a single thread, and all the Unity stuff running in other threads. What you can see here now, if you look at the left side of the screen, you can see all the threads from all the cores in the machine, and they're all running in very, very high parallelism. So we're getting like 95% utilization of the underlying CPU. So that's innovation number one, is the absolute multi-threading with our job system. Number two is it's a little more difficult to show, but I can talk you through it, and that is our new entity component system. Now, the era that we live in today, if you understand computer architecture, we waste cycles on almost every single instruction. And the reason we do that is because of the load store architecture that we have. What this means is that every time you want to fetch some data from memory, you have to pay an overhead if it's not in your data cache. So most programming and most programming languages, especially object-oriented ones, don't do a very good job of laying out memory in a good way. With the new entity component system, what we do is we take the data for every component across your game objects, and we pack it all together and stick it in 64 kilobyte pages. And then when we run the updates on it, that runs across all instances in one pass. So that means your instruction cache stays valid because you have one routine in it, and your data cache is very coherent because you're moving through all of the data that's packed in there. That means no garbage collection whatsoever. Instantiate becomes a mem copy, which is the fastest possible instantiation, whether you use assembly language or a higher order language. And destruction is the same thing. We just have to remove the reference to the pointer because there's no objects, no garbage collection happening. So we can spawn tens of thousands of objects in a single frame, and it's nothing. So it's really, really fast. The third thing that's at work here is our new compiler technology called Burst. We've been working on this for many, many years, and it's finally here. Now, if you see in like this bar that I'm highlighting, it may be hard to see, you'll see the word, there's Burst listed behind it. So what this means is we've compiled it with the Burst compiler. What the Burst compiler is it's a final stage back-end compiler that's math aware. So that means we've taken your code, you've done the compilation, you've compiled, optimized, full release settings, everything, great. Now we have the binary code. We analyze that binary code to see what it's actually doing. We recognize patterns for higher order math functions, and we optimize them and replace them with better versions. And this gets you really, really significant gains. Let's take a look at this for a second. So I've pulled out 4 of the things that we're running in this demo, which is preparing the render jobs. We've got the minion collision job, the behaviors, and so forth. The blue bars are showing you the Burst compiled code and what it's running, and the gray bars are the original mono behavior code. And you can see that we're getting dramatic speed ups. I mean, to be able to get 100% performance increase is almost unheard of these days, and we're getting multiple times that. And so it's really incredible. When you look at each one of these, they each increase performance on their own. The C# job system, the entity component system, and the Burst compiler. But when you bring them all together at once, you get just absolutely insane performance that's going to unlock new extreme use cases. So probably a lot of you are sitting there thinking, okay, that looks pretty cool, and Brett ran it on a machine, and if you were attentive, you saw that it was basically 2017.3 in the upper corner there, so you're wondering, when can I have this? Well, the good news is we'll be shipping the first 2, the C# job system and ECS in 2018.1. That's just 5 months from now. Now, let me give you a little bit more information about how you can get started with this. The C# job system will require you learn some new techniques and ways of coding. If you've ever done any multi-threaded coding, you know how difficult it really is. What's really amazing is because we have our own compiler tech on this as well, that we don't let you, and you can't write bad code. Essentially, as you write the code, you enable the C# job system, we will analyze the code. We detect things like race conditions. We will show you where that condition exists in your code. We'll even show you how to rectify that and suggest what code needs to go where. So it's going to be really, really easy for you to take advantage of. It will probably take you, first time out, 1 to 2 days max. And then once you've got how that works, then you can look at your game and figure out where you want to use it. The best part is this works with everything. So it works with the current Unity systems and games. So you can use this right away. You can have things in your scene that you think would benefit from this, and you can enable it on a case-by-case basis. And it's fully compatible with the entity component system as well. Now the second one, the entity component system, also is going to require a slightly different programming model to learn. It's essentially a slightly reduced subset of C#, so no problem here. I mean, just nothing super, super fancy. And we use it in a very structured way. If you've ever written any kind of shaders or compute type code, it's a bit similar. It's straightforward code based on data that you want to actually parallelize. And this one, if you've ever done pool programming in Unity, then you kind of know what I'm talking about. These will be a good use case for you to use, and you're going to find that it's actually much simpler. So if you're already doing something that uses pools, you're going to find ECS works as you expect. It's going to get you massive performance gains, and it's going to be super easy to use. If you don't know what pools are and you haven't used those before, that's fine, don't worry. It's not difficult to learn. It's just going to take a little bit to work through one example. And again, you can use this just one-off. You can pick one thing in your game that you think would benefit from this. You can put that in, and then you can build from there and learn as you go, and you can mix and match. And again, these all work together. Now, for our new burst compiler, we need a little bit more time to bring that to where it needs to be, and so that's going to be coming later in 2018. Now, the best part of the burst compiler is there's nothing to do, there's nothing to learn. You just enable it, and then we're basically going to run the compiler in the background. We'll look at your code, and you're just going to get optimizations right out of the box. And again, as you saw on the profiler screenshot, these things all work together. So they multiply each other out, getting you up to 50, even 100 times performance, depending on your use case. So to me, this is very, very, very exciting, and it's just a great example, I think, of how Unity is solving hard problems and trying to enable success for all of you. So super, super good for that. Now, we're actually almost done for the day, but before we want to go, we wanted to give you a peek at what's going on here in India, so we put together a show reel of projects made with Unity. Let's take a look.